Okay, 5.1, simplifying radical expressions. Before we start this, remember that you have perfect roots. So that's talking about 1 squared, which gave you 1, 2 squared, 4, 3 squared is 9, 4 squared, 16, 5 squared, 25, 6 squared is 36, and so forth. Remember that when you take square roots, it's basically going in reverse. So instead of squaring a number, we're taking the square root of the number. So here it says simplify square root of 25, which means it's saying what number squared gives 25. And that can only be a 5. When we look at the next one, it says simplify -6 fourth root 243 x to the 19th. So in these type of situations, it says a fourth root. So it means that little 4 is indicative of something. So what we're going to do is we're going to take our problem, -6 fourth root 243 x to the 19th, and I'm separating it into 2 different pieces. So the -6 is still outside, but it's being multiplied. Then we're going to do the fourth root of 243, and then the fourth root of x to the 19th. So in this one, it's saying what number multiplied 4 times, that's what a fourth root means, what number multiplied 4 times gives us 243. So you can treat this as an algebra problem, say x to the 4th power is equal to 243. We want to know what x is. In this instance, the x value in this portion of it is, what number did I take, multiply 4 times to get us to 243? So you can take your calculator and you have a little caret key that's right here. And what you can do is you're going to put 243, hit the caret key, and in parentheses, since it's a fourth root, you're going to go to the 1/4 power and then hit enter. So see, in this one it tells us it's 3.94, which is not a perfect fourth root. So there is no number that gives us 243. So we want to know, what can we break 243 in? First thing we notice, it ends in a 3. So if I take 243 and divide by 3, gives us 81. So we know that 3 times 81 gives us 243. The number 81 breaks down into 9 and 9, which is 3333. So it's a fourth root, which means I can take out a grouping of 3. Here's 4 3s in a row, which means 1 escaped and 1 was left over. So 4th root of 243 is actually 3, 4th root of 3 left over. So it's saying the 4th root. So we cannot take 243 equally. You need to break it down into prime numbers. -6 is still here. So we still have that -6. I'm just sliding it over. Then 4th root of x to the 19th. The variables are the easy part. You're going to use the index and divide by it. So 19 divided by 4. 4 goes into 19. That is 4 times with a remainder of 3 pieces, because 4 times 4 is 16. Plus 3 gives us our 19. So that means x to the 4th came out and 3 stayed in the bucket. So we have this term, we have the one we broke out, and we still have that -6. So all I have to do is bring it back together. So we have -6 times 3, 4th root of the 3, x to the 4th, 4th root of x to the 3rd. Regroup. We can multiply these two numbers right here, giving us -18. Since this happens to be outside, which we consider a whole piece, it's going to join the 18. The part that is left in the bucket, or your root, goes together. So you have a 4th root of 3x to the 3. Now, when you're entering this in any system, depending on how they have the software set up for you, you're going to put this portion here, the 4th root. So you're going to type in -18x to the 4th, do an asterisk for your multiplication. You're going to write the root, and because it's a root 4, 4th root, you're going to write root 4, And then in parentheses, write what's left inside the root. And you stop there. Moving on to the next example. So on this one is dividing, but it says reduce the fraction. So because it's radicals, you're going to split them into two parts. So we're going to write it as square root of 1 over the square root of 169. And then just do the math for each of them individually. The square root of 1 is a 1. Square root of 169 is a 13. On the next one, it's the negative of the radical, which means we already did the answer for this. It's 1 over 13, but because there's a minus sign, you just bring the minus sign to the front of it. On the next example, it wants us to evaluate the cube root of negative 1,000 without using a calculator. And then if it doesn't exist, then it doesn't exist. So something to remember, if it's an even index, means the number in the root here, the root, is a square root, a fourth root, a sixth root. So even index means it's a square root, you're looking at a fourth root, you're looking at a sixth root. Negatives inside do not exist. So they're D and E. Because it's an odd index means it's a cube root, a fifth root, a seventh root. Negatives inside are okay. So let's look at our numbers. It says cube root of negative 1,000. Well, if I think of the negative, I'm going to pull the negative out. Because I know that it's going to be, if negative is inside, we have a negative answer. And it's a cube root. Then we got to break it down. So it says without a calculator. Think of 1,000. 1,000 is the same thing as saying 10 times 100. And 100 is 10 times 10. So notice the thing. We have an index of 3. And we have 3 tens inside. Since the index and power match, you're just taking the inside out. So my answer is 10, but because of the negative, we are negative 10. Next example. So in this one, they want us to find the negative fifth root of 32. So first thing, the negative is on the outside, we're good. Even if it was inside, we would still be good because it's an odd index. So it's asking us what number multiplied 5 times equals 32. So if you think in terms of even roots, it's 32, which means I'm divisible by 2. So I'm going to rewrite this as 2 times 16, which then can break down to 4 times 4, which again, the 4s break down to 2 2s, again 2 2s. So we see that we have the number 2 repeated 5 times, indexes match, so we are negative 2 as an answer. On the next one, it says simplify the fifth root of y to the fifth. Remember, for variables, you're going to divide the exponents by the root. So think of it as y, 5 divided by 5. That results in 1, so we have a y coming out. Here they gave us variables and numbers. So again, because it's square roots, you're going to split them. You're looking at the square root of 4 and then the square root of x to the 48th. So square root of 4, we know that is a positive 2. Now, 40, it's the square root. Remember, it's implied. It's imaginary. We don't see it. There's a little 2 in the corner. So you're taking the number 48 and dividing by 2. That gives you 24. That means 24 x's came out. Another way of thinking about this is you're at a party, hanging out with your friends. In order to leave the room, you have to leave in pairs of 2s. So 48 evenly split means 24 groups left the room. That's another way of thinking about it. And the next one says square root of 16, p to the 42nd. So we have the square root of 16, and then the square root of p to the 42nd. Again, square root of 16, that's a 4. Remember, imaginary 2 is implied. So 42 divided by 2, that is 21 pieces. So p to the 21st came out. Next example. It wants us to simplify the square root of 112 into the form of a radical b. Now here, they don't want you to write in a radical b. They want you to just list what the a value should represent and what the b value should represent. So we have 112. And I think of it as an even number, so I'm going to divide by 2. So 112 divided by 2 makes it 56. If you divide that again by 56, can split into 8 and 7. 8 is 2 and 4. And the 7, and the reason I did this is because those two together mean a 2 came out. Square root of 4 is another 2 that came out. And you have a 7 left over, which is 4 square roots of 7. Now, to verify, go in reverse order. 4 squared times 7. 4 squared is 16, and 16 times 7 is 112. So your answer for A is going to be the 4, and then you're just writing a 7. You're not writing square root of 7, it just wants the value inside it. On this example, it says square root of 17, x to the 17, so x to the 17th, remember, it's an even, so it's implied as a 2, so 17 divided by 2, which means 2 goes into 17. That's 8 times for the remainder of 1, which means 8 x's came out, that's the whole part, and then an x, your remainder, is what stayed in. So the a value, you're going to write x to the 8th. The b value, you're going to write a letter x. Next example. On this one, it says the square root of 81 m to the 7th. So we have the square root of 81, square root of m to the 7th. Remember, square root of 81 is a 9. And then we're dividing by an imaginary 2, so 7 divided by 2. 2 goes into 7, that's 3 times with the remainder of 1. Which means 3 m's came out, that was the whole piece. And then the remainder portion is what's in the radical. So if we link it all together, this portion here represents the A. This value on the inside represents the B. So 9m to the 3rd, and then an m. On the next example, it says square root of 8, x to the 6th, y to the 9th. So I'm going to separate every single piece. Square root of 8, square root of x to the 6th, square root of y to the 9th. 8 is actually the square root of 4 times the square root of 2. If you're looking at your variables, you're dividing by 2, so 6 divided by 2 means 3 pieces came out with a remainder of 0. And then 9 divided by 2 is 4 pieces with a remainder of 1. Square root of 4 we know is a 2 with a radical 2 left over. We said 3 x's came out with none left over. Then we said 4 y's came out with 1 left over. At this point, nothing's grouped together, so we need to rearrange everything. So anything that's on the outside is going to lump together. So 2x to the 3rd, y to the 4th, and then what's in the inside of the radical are going to lump together. So radical 2y. So this entire portion here is going to represent the A. This portion is representing the B. So 2x to the 3rd, y to the 4th, and then 2y is how you would enter your responses in whichever system you're using. Next example. In this example, it says the cube root of 8, a to the 8th. So it's the cube root of 8, cube root of a to the 8th. So in this instance, it wants us to find numbers that multiply 3 times in a row. That gives us 8. Remember, your cube roots, like 1 to the third is a 1, 2 to the third gives you an 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125. So right here we know that the number 2 repeated 3 times gives us 8. So this comes out as a 2. And again, like we said before on variables, you're going to divide by the index. So 8 divided by 3. 3 goes into 8. That is 2 times, because 3 times 2 is 6. With a remainder of 2 pieces, because 6 plus the 2 makes our 8. So the 2 just slid down. We said 2 apples came out, so a squared. And then the cube root of a squared, because there was 2 pieces left over. So this entire thing is a, the capital A, and this entire thing represents your capital B. So 2a squared, and then a squared is what you're going to put in for your system. Next example. So on this one it says the negative 4 fifth root of 243 x to the second. So we're going to first do negative 4 fifth root of 243 fifth root of x to the second. So we look at this. The negative 4 is already on the outside, so we don't have to worry about it. We need to figure out 243. Remember, since it ends in 3, divisibility rules. If it ends in 3, you can divide by 3. So that becomes 3 times 81. And then we know that 81 is 9 times 9, which breaks down to a total of 5 3s. So we see 3 to the 5th power. Since the index and power match, a 3 came out. We still had the negative 4 that was already on the outside. And then when we look here, 2 is not divisible by 5. So we are still the root term. So you end up being negative 12 fifth root of x to the second. So depending on the system, if it has the math type, then you would just pick the root system. If not, you're going to enter it as negative 12 times, remember roots. When you're showing roots greater than the square root, you're going to write the word root. The root is a 5 because it's a 5th root. And then what's on the inside of the root, which is x squared. Next example. In this problem, it says you're locked out of your house and only an open window is on the 2nd floor, 35 feet above the ground. You need to borrow a ladder from one of your neighbors. There's a bush along the edge of the house, so you will have to place the ladder 13 feet from the house. What length of ladder do you need to reach the window? So in some type of problem like this, so they gave us a sketch. So think of this being the wall where the window's at, and the ladder's coming out, and they tell you directions. It says it's 35 feet above the ground, so it means that the height of the wall is 35 feet. It says that you have to place the ladder 13 feet from the house, so it means the distance from where the ladder is hitting the ground to the wall is 13 feet, which forms a perfect right triangle. Something about right triangles, remember there's a thing called Pythagorean theorem, which is a squared plus b squared equals c squared. It's a formula we can use. So A and B are always indicative of where the 90 degrees meet. So A and B is where the 90 degrees meet. C is always going to be the longest side, which is also known as the hypotenuse. And these are your legs. So that means this is where the C value is, which we don't know. So they gave us 2 of the numbers and the missing part. So we have, I'm just writing this formula, a squared plus b squared equals c squared, and we're substituting in. So 13 squared plus 35 squared equals rc squared, which we don't know. Remember, 13 squared gives you 169. 35 squared is 1225. Add your numbers together. So right now we're looking at 1394 is equal to c squared. And since we need to figure out our root, take the square root of the number. And we end up with 37.3 feet. I'm leaving it in decimal form. Normally that's what I would do it as instead of leaving it in rational form. On the next example, it's talking about TVs. So it says, what is the diagonal length of a TV that is 16 inches wide and 10 inches tall? So remember, diagonal is what they're docking from one corner diagonally to the other. So when we look at a TV, it looks like a right triangle is being formed. It says that it is 16 inches wide, so it means 16 is our width, and it's 10 inches tall. So they want to know what the diagonal value is. So again, a squared plus b squared equals c squared. Here's our a, here's the b. 10 squared, 16 squared, c squared. Remember, 10 squared is 100. 16 squared is 256. If you add your numbers together, you get 356. And then we're going to take the square root of that number. And it gives us a value of 18.87. And determining on the system is going to ask you if it wants you to round to one decimal place or to round to the nearest whole number, then this is how you would determine what you want to put in. Next example, it's saying they want us to approximate using the calculator. So all you're doing is taking a calculator and telling us what the square root of 129 is, 119. So it's hit the second key. The x squared gives you your square root piece. Type in 119 and then hit enter. And we get, and it says to round to the nearest hundredth, which is 2 decimal places. So first thing I'm going to do is write 10.908. And the reason being I did that is because it wants us to go to the hundreds. So that 8 made that become a 1, so we are 10.91. On this one, the negative is on the outside, so we're okay. So we know our answer is going to be negative. Square root of 142, again, second, the x squared key, 142, hit enter. Again, I'm writing 11.1916. So I could go to the hundreds place. That 6 is greater than 5, so I become negative 11.92. Next example. So we have talking about radical functions and evaluating them. First thing we need to know about is domains in square roots, when square roots are involved. For the domain values, it's located on the inside. You're going to take the inside and set it greater than or equal to 0 and then solve. So on this one, all they want us to do is evaluate them, but I gave you the domain so that you know that if it's an even root, and this is only on even roots, you're going to find your domains. If it's an odd root or odd index, your domain is going to be all reals, so negative infinity, positive infinity. So if we were to solve this problem right here, I wanted to find out our domain values. What values of x can I be? You're going to say 2x minus 5 greater than or equal to 0 and solve. So you get 2x is greater than or equal to positive 5 because I crossed the bridge. Divide by 2. So x has to be greater than or equal to 5 halves. So my domain would be, bracket, because there's a line, means inclusive, 5 halves, and the arrow tip is pointing to the right, which is positive infinity. That is if they're asking for a domain. Here they want us to evaluate them. All they want us to do is to substitute in the values 3, 6, and 11 and for x. So on this one, we're going to do f of 3. I'm plugging in 3 into the radical, so I'm plugging in a 3. 2 times 3 is 6 minus 5, which is the square root of 1, which ends up in being a 1. Then they want us to do f of 6. You're going to repeat the same process, only replacing x with a 6 now. So we see 2 times 6 minus 5. That's 12 minus 5. So radical 7. And then on the last one, they want us to do f of 11. So we see 2 times the 11 minus 5. 22 minus 5, which is 17, radical 17. And depending on the system, you may have a root value they can use, or you can just write the word square root, SQRT, and then a 7, SQRT, and then a 17, dependent on what system you guys are using. Next example, it says evaluate the radical function. First thing I want to do is I want to identify my domain. Since it's a cubic root, they want us to find f of x of the cube root of x plus 14. Remember, it's an odd index, so the domain is negative infinity to positive infinity, if they were to ask you that. Now they just want us to evaluate when it's negative 8, 0, and 13. So we're going to do f of negative 8. We get negative 8 plus 14, which ends up being cube root of 6. So in order to enter that, remember, you're going to write root of 3 and then a 6, because that's how you're going to show root, cube root of 6. Now they want us to do f of 0. So obviously, when I replace 0, I'm just whatever's left inside it. So I get cube root of 14. So we're going to do root 3 of 14. And then they want us to do f of 13. So we have 13 plus 14. So we have cube root of 27. So remember, 27 happens to be a perfect cube. So we just end up with a 3 as an answer.